welcome there to another episode of the Cliff Notes podcast, where we ask a leader and find a way. Today we're joined by Joern from OEE.cloud. Hello there, Joern.
Hi, Tristan.
Hey, and how are you doing? I wondered whether you could tell us a little bit about OEE.cloud and your background for us today, please.
Yeah, thank you very much. I'm fine, and thanks for having me.
Great. I mean, what's brought you to building this product? A topic or a metric that had interested you before, or it's come up in other work that you were doing?
I'm an industrial engineer, and I worked for many years in the consulting division of the sports car manufacturer Porsche in Stuttgart here in Germany. And so there we often were confronted with the problem that it was very hard to capture the data to get a proper OEE measurement. Not only the collection of the OEE data, but also of the loss reasons. So why did the equipment not perform in the requested speed or the requested performance at all? And this was something we solved, and many companies are still today solving this with tally sheets or an Excel list or whatever. And this is something, we wanted to tackle. And there was a team, or we found a team around a consulting company we founded after our time at Porsche. That wanted to work on this topic. And this is how we developed OEE.cloud.
Great. So, I mean, just to bring that back to maybe people who aren't familiar with what OEE stands for and is useful for, could you just give us a little background to the metrics?
Yeah, definitely. This is a metric for equipment performance. So it's applicable to all manufacturing equipment. And it basically consists of three factors. It's availability, performance, and quality. And each of these factors is a percentage. So you have an 85% availability, 35% performance, and so on. And then this OEE KPI is also a percentage, obviously. And when you lose availability, when you run an equipment, this might be a breakdown of the equipment or an organizational stop. So no material available, no person available, or something like this. When you have a performance loss, you are working with reduced speed. So the equipment is expected to go with 100 units per minute, but you only run the equipment on 80 units per minute, then you have a performance loss of 20%. Or it's short stoppages. So frequent short stoppages are also performance losses. And quality is quite obvious. This is scrap or rework. So when you don't produce products that can be sold to a client. And when you multiply this, you get this OEE KPI, which gives you an indication of the performance of your equipment, or a pretty clear number of the performance of the equipment.
Okay, that's a good description. It's been one of the sets of metrics that's been I found most interesting and exciting with working with partners of how they're using it, and we've even been experimenting with how we could apply it in some of our sort of more technical cases, just to understand what that metric is, as to whether it is the end result and the three parts, whether it's more of a management metric, or do you feel it's more to drive out the defects and the lost performance to improve the overall productivity?
I mean, I think it covers both, because on the one hand, you can, for example, determine if you have the requirement to invest in more equipment. So when your equipment is running on an OEE of 85%, and you still have backlog from your customer orders, then it's time to invest in equipment, because you won't get more performance out of the existing equipment. But when you're running your machine on 25% OEE, then I wouldn't invest in additional capacity, but care about the increase of the OEE factor. So this might be a high-level management view of this KPI. And on the other hand, when you enhance the OEE methodology, not only about this pure number, so that the result is only a percentage, but also about the loss reasons. So the equipment had a breakdown between 10:02 and 10:15. What was the reason? For these 13 minutes, and then it was a mechanical breakdown in equipment unit 3, and the reason was, and so on. So then you get a kind of waterfall where your losses come from. And then you can tackle it operationally with your Kaizen team, with your process improvement team, and then you have a very clear picture on where your low hanging fruits are, and you can measure where if you have picked them, so you can measure the before and the after situation, before an improvement and after the improvement, and then if you have eliminated the root cause of these losses. And this is where the operational part of the KPI is adding value to the company.
Mm-hmm. So it can be looked at over a period of time or review back sort of past shifts, but it is quite a real-time metric too, that you can appreciate that you can affect it. It's not some metric for the end of a delivery or the end of a quarter. It is happening in real time, so you can see if you can stop so many stops or defects or change a process a little bit. It will affect the metric.
Yeah, definitely. I would vote for an online measurement of the OEE, and I would also vote for an and-on board, for example, on top of the machine or in the manufacturing area to see how the equipment is performing right now. And also at the end of the shift, it's interesting to analyze the losses, but after a period of time, so let's say a couple of days or a week, the OEE, the operational factor or the operational benefit of this OEE measure is losing its value. So it's for on-spot optimization, I would say.
Mm-hmm, mm-hmm. And if a business would want to take this on for their workshop or their factory to monitor the machinery, do they need to have a sort of existing process, or does it need to fit into some other system, or is it fairly straightforward to get going?
Yeah, this is the main characteristics of OEE.cloud, that we designed the whole solution without interference with the control system. So you don't need to change your PLC to collect the data. This is a bolt-on, on-top, plug-and-play, you call it, solution that you don't need to modify your equipment. And first of all, one of the reasons or one of the biggest hurdles from my experience to collect the OEE is how do I get to the data? And even if there is a desire to get the data in the management of an operations, the people are hesitant to change the equipment. I mean, the saying is, don't fix it if it's not broken. And so why shall I modify an existing and running equipment? And with the risk that there are then problems with the PLC afterwards. So you rely on this equipment, and this is why people prefer this add-on solution. And this is what we realized, that you don't need to invest in a project, you don't need to invest in IT, you don't need to install anything or modify your equipment to capture very, very precisely the OEE data and also the reasons for the losses.
So it doesn't matter if it was a Mazak machine, a Haas machine, a production line. You can just add to an existing system. It doesn't need to be very modern or very old or in between.
No, we actually cover everything. So machines that don't even have a PLC, we can cover. But also we are surprisingly often working with very modern machines because it's so easy. And the management decides that it's better to attach something than to modify the existing investment.
Great. And so what you said that it was sort of plug and play. It's very easy to add this. I mean, what is the physical requirement to add a piece of machinery, or the clearance you need? Or I mean, what space do you need to add this?
Actually, we provide an IoT gateway, which is a small box, the size of a cigarette box, and there is the whole edge logic included. So there we collect the data, and we pre-process the data, and then we transfer it either via the local area network, so the wireless LAN, or also by mobile data. So because sometimes it's even a hurdle to get in the wireless LAN network in a factory. So this is why we have a solution which is running on mobile data embedded in this box. And we need normal 220 volt currency for running this box. And then there is this IoT gateway box. And then there is a connection to a sensor, which are standard industrial sensors. So think of ZIG or whatever the supplier is. And with this sensor head, we take the movement of the machine in a conveyor belt, or opening and closing a door, or moving of a robot or whatever. So where we can detect the cycle. And so it's a couple of square cubic centimeters. You know about these 6 sensor heads. They are tiny, they are small. This is the size of a USB stick or something like this. And this is the space requirement where we have in the machine.
Great. And so, I mean, what are you monitoring? Are you just monitoring the throughput, or can it see defects or downtime, or what can you monitor with this device?
Yeah, we monitor the throughput. So in terms of, is the machine running at all, and in terms of, is the machine running at the expected speed. And this is basically the only input we need to calculate the OEE, and the rest is done in the backend. So where you can configure everything around your requirements, where you can figure which products you produce, what expected throughput rate each of these products has, what your loss reasons are, when you want to capture the loss. So you don't want to capture a reason for every 60 seconds of losses. So there is a kind of threshold, and these are the things you configure in the backend, and all this put in a row properly is then the OEE.
If you want to start a pilot project with this, can you start it with a single machine, or should you kit out the whole workshop with these?
Actually, we would suggest to start with 2 or 3 machines in a different environment, so that you learn from different specifications, because not all of the equipment are similar or even equal. So to learn more, going a little bit broader is a suggestion. But actually, we wouldn't fit out the whole machinery and each and every equipment with an OEE sensor. We would focus on critical machines. We would focus on bottleneck machines. And this is the focus. So I don't think that you need to cover each and every of the machines, but the ones that are critical for your manufacturing process.
Mm-hmm. So focus on the key bottlenecks first, and improve the overall efficiency. Okay, that makes sense. And is there possibility to get a visual readout either for the engineers working on it, or some central location, so that you can monitor this live?
Yeah, we have actually an undone board is built in, so which is a web page basically, and you can send this web page to each and every monitor display you have, which has an internet access, and then you see real time online what your availability, your performance, your quality is. You get a graphic visualization of the history of the shift, and this is present on every device, so you can run it on every display. You can also run it on your tablet if you want to see it there.
And if the constraint moves because you start running a new product, does that mean you need to recalibrate the sensors or the OEE, or how do you handle this?
Yeah, I mean you can migrate the physical sensor. So it's you need to distinguish between the logical place where we capture the OEE and the physical place where the sensor is located. And you can move the physical sensor to another logical place and then capture the OEE there. So this is what companies do sometimes, that they move the sensor when they set up for another product, or when the constraint moves.
And I learned from talking to you before that you do more than just monitor this. You have some AI, some intelligence to help analyze and look at the data. Where does that come in?
Yeah, this is actually quite an interesting path we are working on. So this is basically a two-step process. First of all, we get the data online, and then we classify them, which is basically a machine learning task. So is this data set what we have received, for example, between 12:10 and 12:13, is this a stable or an unstable production? Do we have many short stoppages or not so many short stoppages? This is the question of the classification, which is machine learning. And based on we can run artificial intelligence algorithms on the data, and we need to train them specifically for the equipment. And then we get interesting insights to the data stream. For example, we can identify a prolonged machine setup. So usually the setup takes 30 minutes, and in this case it took 45. And this what is usual and where is the anomaly? So this is not decided by people. So you don't need to take a look at the data stream and decide as a human being this was an anomaly, but this is decided by the algorithm. Or the algorithm detects a time frame last night, late shift, after 11 p.m. There was a time where we had an extraordinary number of short time disturbances, so short time losses. So this is an anomaly in the data stream, and you could basically you could identify it also as a human being, but being confronted with 20 machines and being confronted with 20 data streams, you don't want to look at this massive amount of data and tag the data in the data stream yourself. And this is what these algorithms are doing, that they identify the anomalies where something is not working according to the usual behavior.
Might pick things up earlier, or just saves people a lot of time of scanning through all this information by hand?
So first of all, so our experience is that this detailed analysis of the data is not done at all. So you have a new insight that you haven't had before. And so we discover opportunities for improvement by this analysis. For example, you can see that a machine or a certain product is running on machine A and has a high OEE, and the same product is running on machine B and has a lower OEE. And so which is then an indicator that you should decide for the machine with the higher OEE. And this is something an algorithm can identify in all of your data. And this is a level and a detail of data analysis. This is currently not available.
Just to get more of an understanding of the sort of commitment to a product like this, have you have some sort of recent examples, or what's a successful implementation look like?
Yeah, I mean, we are working basically with 4 types of clients, let's say. We are working with operation companies that are producing mechanical parts. So automotive companies, machinery companies, suppliers in these industries. We are working with a lot of filling companies. So when you think of fast-moving consumer goods, equipment needs to run to fill bottles or bags or whatever. And we are working with consulting companies, and they are using our product for a quick analysis of the situation on the operation shop floor. And we are also working intensively with the supplier development departments. So when you are, for example, in automotive OEM, like my background, and you want to start your new product, so new electric sports car, for example. And then you have a lot of ramp-up situations, not only in your own factory, but also with the suppliers. And some of these suppliers might be at risk, or this product might be very crucial because you don't have any stock available because the operations or the production situation is tight. And then these automotive OEMs, for example, they are putting these sensors in the equipment of the tier 1 or 2 supplier to have an online view if the required number of products is produced, and that they can manage the supply chain and have more transparency in their inbound supply chain. These are basically the four groups of companies or four groups of customers we are working for. And yeah, we have cases and experiences in all of these businesses.
So if a business wanted to be able to come to you and they've been in one of these sectors, then you can be able to advise them some plans and the way that these other businesses have been successful with this.
Yeah, so basically on two sides. So one is it providing this non-invasive technology to capture the data and to identify the opportunities, and then also to work on these opportunities. This is a potential second element in our cooperation, which is sometimes also requested.
Just to then round out, I mean, what's the typical sort of return on investment of this? Does the technology itself have the ability to drive a good percentage more business, or it's just about improving overall effectiveness?
Yeah, I mean, you get more out of what you anyway already have. So I mean, you are paying for your equipment, you are paying for your employees working with the equipment, and now we improve productivity. And to give you an indication, when you and these sensors, we haven't mentioned this so far, but you rent them on a monthly or yearly base. So when you have an hourly rate for a machine, let's say of 150 or 200 euro or something in this dimension, and this is easily reached with modern manufacturing equipment, then and you work on 2 shifts, for example, with this 150 euro per hour equipment, you need to identify improvement opportunities of 20 minutes per month. So if you get 20 minutes more operations time per month using our equipment, you have paid for our fees. And each and every minute above 20 minutes more over this month is your benefit.
So if a line or a particular machine is only running at sort of a 60% efficiency, and you can get it up towards 70 or so, the return on investment is going to be a fast following.
Yeah, I mean, it's huge because you don't have additional costs, but you only get additional products. I mean, there's not much to calculate.
It's a no-lose situation. It's just going to make everyone more efficient.
Yeah.
That's great. Well, thanks very much for your time here today. It's been a real education to see how you've been able to lift this and not require new and changes to existing machinery. It can just work alongside. Is there any way that people are interested to learn more or be able to start working with yourselves? where can they come and find out?
Yeah, first of all, you find us obviously in the internet at the domain OEE.cloud and also at the domain OEE.ai. So we are running these both domains. We all of our team is also on LinkedIn. So get in touch with us also on LinkedIn. You find us when you search for OEE.
Great, we'll put those on, and we'll look forward to hearing more and hearing more successes of people being able to implement this and up their efficiencies.
Tristan, I'm looking forward to this.
Thank you for joining us today on the Cliff Notes podcast. If you'd like to get in contact with myself or join the guest afterwards, please do so on the website cliffnotespodcast.com. or on Twitter @CliffNotesPod.